X component of force C. Yes, similarly, the Y component of force C may be found in a similar manner using the formula. Note, both symbols mean that the quantities are vector quantities and thus depend on their direction or on their directions. They can be negative, positive, or negative. This must be considered when adding them as well. 1. We're going to assume that the forces are created by suspending the masses of the end of the force table, as in figure 1. 2. For this mass, or for the mass given, find the corresponding force created in the string used to suspend the mass. So now let us go to table. Let's go to the table down at the bottom here. So this red thing, this round thing is supposed to be the force table, yes? But in the table at the bottom, we see A and we see 2.200 kilograms. So we're going to assume that to create force A, we are suspending 0.200 kilograms of the end of the force table. B is 0.200 kilograms. We're going to assume that we are suspending a mass of 0.200 kilograms again of the force table. Yes, so that is what it means here by assume that the forces are created by suspending masses of the end of the force table, as in figure 1. Figure 1 is here. See mass suspended of the force table. 2. For the masses given, find the corresponding force. So you're given a mass, and the mass is suspended, you need to find the force. So in the table where it says magnitude, you write the force of the vector. You need to write the force corresponding to suspending the mass. Yes? Rook, are you with me so far?
Yes, sir.
Rook, I'm going to sleep. No wonder you wanted to record. 3. Fill in the blanks by using the component method to find the unknown components and accordingly the resultant vector of its components. So if you go back to the table, they ask you for the X component of this force and they ask you for the Y component of that force. Similarly for force B, they ask you for the X component and for the Y component. Note they told you the direction that the force is to be acted. Yes? So if you know the direction of the force, you know its magnitude. I am sure everybody in my class now, having done the exercises, can find X and Y components. I'm so proud of you. Okay. Now 4, everybody good with that so far? So we can fill out the table. Yes? Is there anybody who cannot fill out this table? Look at the table.
Yeah. I guess I'm a little confused. Okay, you said once we know the mass and they're suspended by 200, we should be able to find the magnitude.
If you know a mass of 0.2 kilograms is suspended, what force does it create? Denny, you with us?
Yeah. So we're using the table at the top?
Table at the top.
No, I mean that big circular ring.
No, the circular ring. We don't come to the circular ring yet. Circular ring can't help us right now. All we're doing is filling out this table.
Oh, sorry.
Yes? No, we come to the circular ring. We'll tell you what to do with the circular ring just now. Don't worry. Tell you what to do with it just now. Let's just focus on the table. So can everybody fill out the table? You can find the magnitude of the force and you can find its components given its magnitude and its direction. So far, so good? And as Denny was asking, how do you do that? Well, you have magnitude and direction of a force, and we did that several times in class, right? So, and you did it for exercise as well. So you can find it. Don't think of anything else, just think of magnitude and direction of a force and components. Is everybody good with that?
Yes, sir.
I'm still waiting.
Somebody answered yes, sir.
That is somebody. That is one person. Are there any questions? Cousin, you have a question?
Sir.
Okay. Ruka, you have a question? Ruka, are you still with me?
I'm trying to keep up. I'm trying.
I have a question. So the mass will be the same for all in the first table, right?
No, all the different force tables going to have different masses. See, this one has 0.2 and 0.15. So we're going to give you different masses. Just the first one, the two masses are the same.
Okay.
Okay, so good.
So how do we go about calculating the mass?
How do we go about calculating the mass? No, the mass is given.
For C, I talking about for C.
For C, oh,
That's
oh,
for C.
oh, oh. Well, notice that C is going to be the resultant of A and B. Isn't that true?
Mm-hmm.
Yeah, so if you find the resultant of A and B, you know what the force of C is, and then you work out your way back to the mass of C, to the corresponding mass. You see what yeah? You get it?
I think I have an idea.
You have an idea. You have an idea. Okay. Let's continue reading and see now. Okay, so after you fill out the table, so you're given A and B, and you expect to find the C. Yes, you can find the components of A and B. Then you can, therefore, you know how components add. You can find the components of C, because C is going to be, if we add A and B, we get minus C. Yes, so we're going to know the components of C. Yeah, notice this equation here. This equation says, how can I highlight the equation for you? By using a highlighter. By using a highlighter. Highlighter. So this equation here, yes, it says that C is minus A plus B. So if we know A and B, we can find C. And similarly, if we know the components of A and B, we know the component of C. Yes? Right, I think we read that somewhere. Yes, it says, thus if X components of A and B are known, then so is the X component of C. Yes? If you know the X component of A and B, you also immediately know the X component of C. And similarly, the Y component of force C may be found in a similar manner using the above. I hate the word formula so much. Let us change it. Using the above equation. It's an equation, it's not a formula. Formula is what you feed babies. Okay. So, good joke, laugh.
Oh, Jesus.
Hey! Hi!
Come on, Nashon, you know you want to laugh.
It's getting me way.
That was just off the wall.
What do you mean?
Maybe I just
Yeah, but where I come from?
They should not use the word formula. You see, it comes from the philosophy of physics and how our students try to learn physics. Our students try to learn physics as a set of formulas that they plug numbers in, and so they struggle because that is not what physics is. Physics is a set of ideas, and the idea is what you must first get. And when you get the idea, you express it as an equation, you express it mathematically. So it is an expression of an idea. It's not a formula. And so this difference determines how people treat the physics and how easy the physics appears to them. The people who have a formula struggle with millions of formulas, yes? But the people who have equations, then the physics become trivial. Physics is always trivial when you do not have formulae. So I guess I disagree with the person who wrote this tremendously. All right, let's go back to number three. So we fill in the blank, yes? So fill in the blanks by using the component method to find the unknown component and accordingly the resultant vector and its component. So that was Shanae's question, yes? How do we find C? So you're going to use the component method and the equation, the highlighted equation, to find the unknown components and the unknown vector. Yes? So far so good? Then we go to 4. Then they say use a protractor and ruler, draw to scale and label the vectors and their respective components to scale on the diagram provided. We draw it to scale. Why are we trying to scale twice? Okay. Using the parallelogram method, draw and label the resultant vector. Okay, so that is where, so, Dene, that is where the
Yes, sir.
comes in.
Okay.
So in number 4 is where the force table comes in. You want to draw to scale the vectors. So you want to draw vector A. Vector A is going to be whatever magnitude you found at 30 degrees. So I'm going to take the protractor. Well, you don't really have to take the protractor now, right? You can just take the ruler. What's the ruler? The ruler on here. Oh, that's interesting. There's no ruler on this one. There's no ruler on Word. There's ruler in. No ruler. That's interesting. Okay, so if I had a ruler, I would put the ruler down and draw my force at 30 degrees. Well, I don't want to draw with a highlighter now, do I? So you draw with a pencil. I think I can do this another way. So I'm going to draw at 30 degrees, exactly 30 degrees, so you back it out correctly. In the direction of 30 degrees, if I had a ruler, that would help me. In the direction of 30 degrees, I'm going to draw a vector that represents vector A. So I'm going to draw vector A. Maybe if I just include a shape. Okay, so include a shape. No, this won't work neither. But everybody gets how you draw a vector, right? Delete that from there. So you draw a vector in the direction of A, right? Then you also draw a vector at 120 degrees. So right here, you're going to draw a vector 120 degrees. So something like this. And you draw B along that line. So there's going to be B here, there's going to be A there, A. So you're going to draw the vectors. Now you need to draw them to scale. What do we mean by that? What do we mean to draw them to scale? Anybody kind of want to help us with that wording, to scale? It says draw them to scale. Taylor, what do they mean draw them to scale?
They have to be accurate.
They have to be accurate. Yes, that is true too. But Taylor, you want to tell us more precisely what we mean by to scale?
They would give you a scale to use, so you have to use that. Show what the scale was.
Is it to get a better measurement?
Okay. They didn't give you a scale. You have to make up a scale. So you have a magnitude for your vector, yes, and you want to represent it on the diagram. So you're going to make up a scale. You have to make up a scale. You can make up a scale, any kind of scale you want, maybe like 5 centimeters will represent, it doesn't write here, 5 centimeters. So your scale might be 5 centimeters will represent 1 Newton. I'm just saying that as an example, yes? Or 2 centimeters will represent 1 Newton. And since you know the magnitude of the force here, then you draw a line proportional to the magnitude of the force, so that the length of the line, when I use this scale, will be the same as 1 Newton. Is everybody with me on that? Do you see what we expect you to do?
Yes, so.
You can repeat it one more time, please.
Yeah, sure. Okay, so you have a magnitude of the force. Let us say this force turns out to be, I'm going to write a ridiculous number, 10 newtons. Yes? 10 newtons. That is not the correct number, of course. It's not 10 newtons. But let me just use that as an illustration. It is 10 newtons for this force A, and A is 30 degrees. So I need to draw a line that represents 10 newtons. Okay, so if I use a scale of 5 centimeters to 1 Newton, then 10 newtons would be how many centimeters? How many centimeters would be 10 newtons? Chad, right? How many centimeters would represent 10 newtons?
E50, but what about your hands up?
Chad, right? Are you with me?
0.1 newtons.
What?
No, Chad. Where, you were sleeping, Chad?
Will it be
Wake up,
50?
bro. Wake up, wake up, wake up, wake up. If 5 centimeters represents 1 Newton, and I give you 10 centimeters.
Oh yeah, 50.
How many centimeters?
Yeah, 50.
You wake up now. Thank you, bro. Thank you. 50 centimeters. Yes, 50 centimeters. So you're going to draw a line 50 centimeters long. Of course, this is ridiculous. I cannot do it. 50 centimeters long to represent vector A. So this is going to be 50 centimeters, yes? 50 centimeters long to represent vector A. So this scale is a ridiculous scale if I'm going to have 10 centimeters. So I have to come up with the correct scale. By trial and error, maybe come up with the correct scale. Maybe I can use 1 Newton is equal to 1 centimeter. And then this will be 1. I think 1 is not going to be big enough for your diagram. So this is going to be now 10 centimeters long. So A at 30 degrees is going to be 10 centimeters long. So depending on the scale you use, if you use a scale that says 1 centimeter represents 2 newtons, then for 10 newtons, I'm going to have 5 centimeters. So 5 centimeters. And so everybody understands it's just a simple ratio, yes? So you make 1 centimeter represent a certain number of newtons. And if you have some newtons, you can find the centimeters. Yes, a simple ratio, simple ratio. And then that is called your scale. And so with your scale, if you have 10 centimeter force, in this case, this 10 centimeter force is going to be 5, this 10 Newton force is going to be 5 centimeters long. So I'm going to draw a line 5 centimeters long. I think this is about 5 centimeters, yes? And that is going to be a 10 Newton force. Is everybody with me on that?
Yes, sir.
And similarly, that's one person. And similarly, B is going to be 10 centimeters. So B is 10 centimeters. It must be represented by B is 10 newtons. It must be represented by 5 centimeters. So I'm going to draw another line 5 centimeters long. Yes. And this will be 10 newtons as well. But it is 5 centimeters if I were to measure the centimeters, yes? 5 centimeters, because each centimeter represents 2 newtons. So this is 2 newtons here, 4 newtons, 6 newtons, 8 newtons, 10 newtons. Yes, is everybody with me on that? And so you draw your scale diagram, yes? And then what else you need to do on the scale diagram? You do the draw to scale and label. So you label the vectors. So you label vector A. So this is A, which is 10, 10, and this is B, and this is B, which is also 10 newtons. So you label the vectors, and their respective components. So you're supposed to draw their components in as well. So you're supposed to draw the x component of A and tell me this is AX. So I don't know where AX will be, and let me kind of put it here. Maybe AX is down there, yes? And let me draw it in a different color. So if AX is down there, you want to draw AX as well. Do you think AX will be down there? So if this is AX, you want to draw AX as well. Yes? And then, so you want to draw their respective components to scale as well, not the same scale. Yes? Same scale. And using the parallelogram method, so yes, the parallelogram method, draw and label the resultant. Do we remember what the parallelogram method is? Edward, what is the parallelogram method?
I don't remember.
You don't remember? Jaron Fowler, what's the parallelogram method?
I don't remember.
Anybody remembers what the parallelogram method is?
When you put a line between the two, I guess.
Justin Fowler, do you remember what the parallelogram method is?
No.
Oh. Roka, tell us the parallelogram method, please. At least somebody must know. Or the triangle method. Do you remember one of those?
So that wasn't right?
No.
No.
The parallelogram method is when you put them tail to tip, right?
Yeah, when you put them tail to tail. So you're going to put vector B here?
That's finding the sum or resultant of two vectors.
Yes. It does say use the parallelogram method to find the resultant, doesn't it? And you put B here, and the resultant is going to be this. So do the parallelogram method, yes? You put them tip to tail. Thanks, Lachelle.
Do you say the resultant is the line between the two?
The resultant is from where you start to where you end, yes. Okay, so since you did not remember, I hope that doing this exercise repeatedly will burn it into your brains. That is my hope. So I guess that is why they gave you the exercise, because they know you don't remember the stuff. Oh, wow. Oh, okay. All right, so go try. I'll sit here and if you have questions.
You could go back up, please, to where you had the drawing. Okay, thank you.
Maybe if you turn off the noise in the background, you might hear better and understand better, you focus a little more.
That's my auntie, that ain't even me.
Tell your auntie to turn off the TV, you're learning. I know this. You did see the distractions at home will challenge online. I remember you saying that. I understand. We understand, but we try to see what can be done. All right. Okay, so note, show all the equations that you use to calculate the unknown quantities in the table. So don't just put in numbers in the table, show us how you get them. You can use the blank space below the table or a separate piece of paper, just use the blank space below the table. Yes, all of this space for working. All of this space is for working. Yeah. Use the blank space below the table. Where were we? Use the blank space below the table or a separate piece of paper for the calculations. List the list of equations, list of equations that you must show in your report, yes, as follows. You must show the trigonometric functions that you're using. Is that a formula? You must use a plus b plus c is equal to 0 and ay plus by plus cy is equal to 0 to find the x and y components of vector c in each case. That is for 1, 2, 3. And in the case of 4, then it's going to be ax plus bx plus cx plus dx is equal to 0. And ay plus by plus cy plus dy is equal to 0. And of course, we also expect you to use the Pythagorean theorem. You are going to also use tan theta for angle calculations, yes? And note that when you use tan theta, the angle is determined from a reference axis depending on the x and y components and their signs. You need to know your reference axis and express your angle from positive x-axis and counterclockwise. So just like we said, we really want to measure all angles, yes? Starting from the positive x-axis, going counterclockwise to the vector. I think we've stated that repeatedly, and we did lots of exercises like that. So you should be comfortable with that. And of course, you're going to use that weight is equal to mg to calculate the mass or to calculate the force, yes? So we've told you everything. Is there anything? Is there anything that you're unclear about?
Just to make sure, you said that you're making our own scale, right?
Yes, you're making your own scale, Shania.
Okay.
Yeah, so depending on the size of the force that you have and the size of the paper, yeah, you pick an appropriate scale that it will represent it appropriately on the paper, yeah?
Okay.
Cool. Any other questions? Why Shania is the only one asking questions? Somebody else ask a question. No questions?
I have a question.
Yeah, man, ask a question.
Can we go over projectile motion before doing this quiz?
But I want you to try the lab first and see if you can get it. No, but some people are not going to get it 80 and they're not asking questions now, but when they go home, they're going to tell, and I'm tired of marking labs and not giving everybody. I want everybody to get 100. 100. Yes? So let them try. And then they will see what questions they have while they're trying it. Yes? So people go on and try. Start trying, please.